Hey, bro, I got your stupid crown. Oh, shit! Got 3,000, motherfucker. Treat? Treat? You are not an elf. You look like Auntie Ethel. Chapter 6, Computing. This should be an easy chapter, I'm thinking. That's what I'm thinking now. That's what I'm thinking. Damn, there's a lot in this one too, actually. I'm thinking we just do this one tonight and then move on to some like other stuff. Like I have a Monster Hunter Wilds video I kind of want to watch. I bought the Wizard game long ago, but never played it. Hogwarts Legacy, kind of want to get to that too. But first things first. Yeah, let's do some fucking Boot.Dev. All right, so Python numbers. In Python, numbers without a decimal point are called integers. Just like they are in mathematics. Integers are simply whole numbers, positive or negative, for example. 3 and -3 are both examples of integers. Arithmetic can be performed as you might expect. 2 plus 1 equals 3, 2 minus 1 equals 1, 2 times 2 equals 4, 3 divided by 2 is 1.5, a float. This one is actually a bit different. Division on 2 integers will actually produce a float. A float is, as you may have guessed, the number type that allows for decimal values. Assignment. Complete the missing sections of the calculate damage function. Fix the total damage variable so that it contains the sum of all the different weapons and spells damage values. Fix the average damage variable so that it contains the average of the combined weapon and spell damage. It contains the sum of all the different weapons and spells damage value. Okay. Sword, arrow, spear, dagger, fireball, fireball, Jesus Christ, ball, and then average damage. And it's everything added up, then divided by how many there are. So 1, 2, 3, 4, 5. We'll do this. Paste. I believe you're gonna want this in parentheses. Divided by 5. That should be it for that. Yep. Integers. In Python, numbers without a decimal point are called integers. Okay, we already read that. A float is, as you may have guessed, the number type that allows for decimal values. My float. Integers and floats. It's a video? Yeah, that's a video. Floor division. Python has great out-of-the-box support for mathematical operations. This, among other reasons, is why it has had such success in artificial intelligence, machine learning, and data science applications. Floor division is like normal division, except the result is floored afterward, which means the result is rounded down to the nearest integer. The bop integer operator had the bop operator. // operator is used for floor division. What the fuck did they call it? The bop. Bop. Floored. In mathematics, the floor function is function. I should read this, but My brain right now is that like too long, didn't read, not doing it. So let's watch the video.
Let's talk about floor division in Python. But before we jump right into floor division, let's do a review of regular division. And run through some examples. So 6 divided by 3 evaluates to 2, because 3 goes into 6 twice. 8 divided by 2 evaluates to 4. Hopefully none of this is too new, because 2 multiplies into 8 4 times. Things get interesting when we divide by a number that doesn't evenly go into the first number. So 6 divided by 4 actually evaluates to 1.5, which, as you can see, has a fractional part. And in Python, like we covered in an earlier lesson, this is called a floating point number. Floating point number. Floor division allows us to eliminate floating point numbers. And it does that by always rounding down. That's why it's called flooring. It goes down. So, in Python, the operator for floating point division is a double bar, like that. So 6 floor divided by 3 actually evaluates to the same thing. It evaluates to 2. Things get interesting, again, when we divide by a number that doesn't evenly go into the first number. So 6 floor divided by 4 actually evaluates just to 1. Right? It's the same as normal division, but with the floating point portion truncated or removed. So a couple more examples. 9 floor divided by 4 would evaluate to 2. Right? 20 floor divided by 8 would evaluate
20 floor
to 2 as well.
Alright, answer this would be 5. Exponents. Oh, good. Python has built-in support for exponents, something most languages require a math library for. Raised 3 squared, raised 3 squared, 3 raised to the second power. That's how you do an exponent? Sometimes exponents are also shown in text using the caret symbol. Okay, that's how I'm going to show my exponents instead of doing that shit.
Let's talk about exponents in Python. And
why would you want to use an exponent instead of just using the number that the exponent would represent? I guess for like more customization, maybe.
And as a review, really quick,
but it would still only be able to be a multiple of like 5 or 3.
So 2 multiplied by 2 is 4. 2 raised to the third power is actually the same as 2 multiplied by 2 multiplied by 2, which is 8. So 2 to the third power, written up here in superscript, is the same as 2 multiplied by itself 3 times. Another example, we could do 3 raised to the fourth power, which is the same as
3 times 3 times 3 times 3. 3 times 3. 9. 9 times 3.
3 multiplied by itself 4 times.
Who knows?
Who
knows times 3?
81. A couple more quick examples. 4 raised to the first power is, you may have guessed it, just 4. And 5 raised to the 0th power. 0th?
Calm down, it's just a freaking ginger ale.
Evaluates to 1, actually. Anything raised to the 0th power is always 1. Okay, so that's how exponents work. Now let's talk about how, what that has to do with Python. The math is the same, right? Math doesn't change. Exponents still work the same way. The syntax is a little different. Instead of writing 2 raised to the 3rd power in superscript like this, we don't do this. We use the exponentiation operator, which is a double star. So that's the Shift 8 on your keyboard. Right, and that evaluates to 8. So to be clear, right, a single star in Python, 2 star 3, that's just multiplication. It's the double star together that represents the exponentiation operator.
8. Changing in place. It's fairly common to want to change the value of a variable based on its current value. Player score equals 4. Player score equals player score plus 1. Player score now equals 5. Player score equals 4. Player score equals player score minus 1. Player score now equals 3. Don't let the fact that the expression player score equals player score minus 1 is not a valid mathematical expression be confusing. It doesn't matter. It is valid code. It is valid because the way the expression should be read in English is assign to player score the current value of player score minus 1. In this operation, the right-hand side, player score minus 1 is calculated first. Once we have the result, we update player score with this new value. Complete the update player score function. It should add increment to current player score to current score and then return the new current score. If there are multiple ways you can do this. All right, so it should add increment to current score. Current score equals we can still do this. New current score plus increment. Earn new current score. I really need that print for that. Just want to do it. Plus equals. Python makes reassignment easy when doing math. In JavaScript or Go, you might be familiar with the plus syntax for incrementing a number variable by 1. In Python, we use the plus equal in place operator instead. Star rating equals 4. Star rating plus equal 1. Star rating is now 5. Other operators. The other in-place operators work similarly. Yeah, I'm about to copy paste all this. Mm-hmm. All right. Nice. Assignment. Complete the get hurt function. It should use the minus equal and place operator to subtract damage from current health and then return the new current health. You cannot use minus equal in a return statement. Set the variable for first, then return it after. All right. Uh, Equals current health minus equal damage. That's the way I'm thinking about it. But I'm not sure if you can you have that and that in the same line? I'm not even sure. No, you cannot. All right. Oh, hold on. Current health. Get rid of this pass. What about now? Still no. Okay. I thought so. I thought that was still going to be an issue. All right. So cannot use vertical in a return statement. So how would you work around that? It should use the place operator subtract damage from current health. Ain't gonna work. Yeah, I didn't think so. All right, so what needs to happen first? Returning the new current health, that's fine. To subtract damage from current health. Damage from current health. This should be simple. What am I missing? So there's something missing in my head that's not clicking. It should use complete the get hurt function. It should use in place operator subtract damage from current health. Don't give me no solution yet. Okay. So that's right. 900 in damage. So we should be getting 840. Oh, hold on. I think I gotta put that under this one, right? Because of the way it gets red. Current health should equal 840. Yeah. I can return again. That should make it run. There we go. Ah. Every second my brain expands another inch. I'll be Jimmy Neutron before the night's out. Submitty committee. Scientific notation, you're killing me with this one, dog. I'm gonna be, I don't even remember scientific notation correctly. That's how many decimal points is behind the first number, right? Like that says 16E3, 1, 2, 3. Yeah, that's exactly what it is. It's not hard to follow, it's just annoying to do. As we covered earlier, a float is a positive or negative number with a fractional part. You can add the letter E or big E, followed by a positive or negative integer to specify that you're using scientific notation. Blah, blah, blah. If you're not familiar with scientific notation, it's a way of expressing numbers that are too large or too small to conveniently write normally. In a nutshell, the number following E specifies how many places to move the decimal to the right for a positive number or to the left for a negative number. Underscores for readability. Python also allows you to represent large numbers in the decimal format using underscores as the delimiter instead of commas to make it easier to read. That does kind of make it easier to read, not gonna lie. Just a tad, just a tad. My assignment, your assignment, our assignment. Due to the constraints of our app server, there is a maximum number of players we can have on a single Fantasy Quest server. Complete the max players on server function. It takes no inputs, but simply returns 3 static numbers. The max players on a small server, god damn. The max players on a medium server, god damn. The max players on a large server, giggity god damn. Use scientific notation to represent these numbers. For example, killing me. I hate you. Gross. Numbers in scientific notation are floats. For example, 1 point blah 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 is actually equivalent to blah 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 blah. Note the 0.0 at the end. This is expected and perfectly fine for this assignment. All right, Big Daddy, I understand you. I didn't understand you. You started giving me gigantic ass numbers and my brain went, whoa, gross. But I get you, I get you. We'll get it done. Eventually. When are we done? I don't want to be here anymore. Oh, can I just put... Let me see this. Can't I just do like this shit? I mean, I should probably be typing it out myself, even though it has the things right there. Yeah, fuck it, why not? Let's just type it out ourselves so we know what we're looking at. Let me look at this thing again. Why is that? Why did I got that decimal point right there for? $18. So from that one to no 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You know what? Why am I doing that? It's literally just 18, 19, 20. Alright, it's just that it takes no inputs. And I just put in like 3 of them bitches. Like, is that even gonna read? Fuck it, we'll see something. Okay, so 1 passed, 1 failed. No, it says 1 passed, 0 failed. That mean I did it right? Submit it. Yeah, I did do it right. Okay. See, I gotta be more sure of myself because I was thinking, oh nah, man, you did this wrong. No, bro. No, bro. You did it right. The logical operators. You're probably familiar with the logical operators and or you're probably familiar with the logical operators and or. Jesus Christ, and or. And or. Logical operators deal with Boolean values, true and false. The logical AND operator requires that both inputs are true to return true. The logical OR operator only requires that at least one input is true to return true. Okay, so number 1, I'm taking this. This is mine now. We'll put this in my notes. Paste some of that as well. For example, paste. So this is the and. True and true equals true. True and false equals false. True, false and false equals false. True or true equals true. True or false equals true. False or false equals true. So you need two falses when using an or operator for it to be false. And you need two trues when using an and operator for it to be true. And these two are interchangeable. If you're using an or and one is true and one is false, it can be true. It will be true. And if it's true and false, with the and operator, it'll be false. Oh, Python syntax. I'm just taking all these notes, man. Nesting with parentheses. We can nest logical expressions using parentheses. Fuck it, I'm just gonna take all of those actually. Screw it. Screw it, daddy, screw it. Pause, don't clip that daddy part. I didn't mean it. Copy icon. Get the fuck out of here. Get out of here. Goodbye. You don't need all the copy icons. Make sure it's reading right. Same. First, we evaluate the expression in parentheses. True or false, it evaluates to true. Print true and false. First, we evaluate nesting parentheses. We can nest logical expressions using. What does nesting even mean? Like, what's the? What does that mean? Placing one construct inside another. Here are a few common examples. We can nest logical expressions using this. Okay. First, we evaluate the expression in parentheses. Oh, okay. Okay, I understand what you're saying. I understand what you want. What does this code statement evaluate to? True. I had to think about it for a second. I don't know why you would write all of that. Well, I guess I can. If it's part of a larger part of code, and like it can make these variables change, I guess. I shouldn't say variables. Fucking logical operators. Well, no. The and the or are the logical operators. The values could change. Not. We skipped a very important logical operator. Not. The not operator reverses the result. It returns false if the input was true and vice versa. Not true, that means it's false. Not false, that means it's true. That makes sense. Taking all of these. This is the type of stuff that I like need. Operators and, or, and not are logical operators. Binary numbers. Binary numbers are just base 2 numbers. They work the same way as normal base 10 numbers, but with 2 symbols instead of 10. Base 2 binary symbols 0 and 1. Base 10 decimal symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Each 1 in a binary number represents an ever greater multiple of 2 in a 4-digit number. That means you have the 8's place, the 4's place, the 2's place, and the 1's place. Similar to how in decimal you would have the 1000's place, the 100's place, the 10's place, and the 1's place. 8's place, 4's place, 2 place, 1. Binary in Python. You can write an integer in Python using binary syntax using the 0b prefix. Prints 1, prints 5. Okay, so if this is the 1's place, that's the 2's place. That's the 3, no, not the 2's place. This is the 4's place. Okay, so this is 1, and that's 4. 1, 0, 4, 0. Okay, so that's 4, and that's 1. I think I understand that. What does this represent in decimal? Okay, so 1's, 2's, 4. Okay, so that's 4. This is in the 8th place, so that should be 12. We'll also watch this video, but I'm pretty sure it's 12.
Let's talk about binary numbers. Before we jump right into binary, let's review what decimal numbers are. Decimal numbers are the numbers we're already familiar with, and it's also called a base 10 system. Decimal, base 10, kind of the same thing. It's called that because there's 10 symbols that we can use to represent numbers. 3, 4, wow, that's just a really bad 3, 5, all the way down to 9, right? 0 through 9, 10 symbols. The interesting thing is when we run out of symbols. Like, what do we do when we run out of symbols, right? So we've got 9 over here, kind of representing nine discrete things. But what happens? What happens when we want to represent a 10th thing? Well, what we do is we create a new, we call it a new place. We call it a tens place. Tens place. And by using the tens place, we can kind of wrap around, right? So the number 10 consists of 2 symbols, where the first symbol is just 10 multiplied by that number. So for example, here, we're multiplying 1 by 10, so we get 10, right? And then 0 by 1, this is the ones place. So we get the number 10, the ones place. All right, so like 15, for example, we multiply 1 by 10, getting 10, and then we multiply 5 by 1, getting 5, so 10, and then we add them together. 10 plus 5 equals 15. Right, let's use just a little bit bigger of a number so we can see this kind of again in action. Let's do 37. So in the tens place, we've got a 3, so we do 3 multiplied by 10, which equals 30. We've got 7 in the ones place multiplied by 1, which equals 7. And then we add those together. We add 30 and 7 together to get 37. 4 humped 3 is killing me. 37. All right, last example in decimal. Let's do an even bigger number. Let's go up into the hundreds place. So 266. So this is now the hundreds place. So we multiply 2 times 100 to get to equal 200. We multiply 6 by 10 to get 60. We multiply 6 by 1 to get 6. And again, they add up to 256. and 66. Okay, so that's how decimal works. Now let's jump over into binary. So binary is really not that different. Binary is a base 2 system. You may have heard that computers talk in ones and zeros. That's because they talk in binary. So there's only 2 symbols in binary. There's a 0 and a 1. So again, the interesting problem in binary is what happens when we run out of symbols. So, 0 represents nothing, 1 represents one thing. How do we represent 2 things? Well, we just use the same system we did in decimal, but instead of the tens place, we're going to create a twos place. So in the twos place, we can place a 1 and a 0 in the, again, this is the ones place. And that represents 2 things, right? Because 1 times 2 equals 2, and 0 times 1 equals 0. And we add those together to get 2. Okay, so let's just keep counting. Let's just keep counting up in binary and see where we get. So we want to represent 0 things, we use 0. Represent 1 thing, 1. Represent 2 things, 1, 0. So this is 2. 3 things, we put a 1 in the twos place and a 1 in the ones place. So 2 plus 1 equals 3 in decimal. Again, we're writing decimal on the right-hand side, binary on the left-hand side. If we want to go up to 4, again, we're out of symbols, or we're out of places and out of symbols, so we add a new place. So this is the 4's place. 4's place. Right? And then 0, 0 to get 4. Jumping down a bit, 5. 6, 7,
Well, I'm gonna tell my grandma I can read binary now.
and 8. Add an 8's place. And that's how binary works.
Yep, because that's 1, 2, 4, 8. That's 1, nothing's there, so it's nothing. That's 2, nothing's there, so it's nothing. That's 4, so that's 4. And that's 8, so that makes it 12. Binary blah 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 is equivalent to which number in decimal? 1, nothing there. 4's place, so that's 5. 8, that should be 13. What's the largest decimal number you can store in 5 digits of binary? 5 digits of binary? I'm new at binary, so don't pick at me. I need to write it out in front of my fucking face. It's not hard, but I still need like the visual thing right now. Six 20. No, that's incorrect, ain't it? No. Because, thousands place, hundreds place, the tens place, and the ones place. Well, now I'm confused because 5 digits of binary. Okay, let me do this again. All right, so I thought I knew what the fuck was going on. I no longer do. What's the largest decimal number you can store in 5 digits of binary? Is this a trick question? No. All right, let's start over. First place, that's the ones place. Second place, that would be the twos place. Then we would have the fours place. Then we would have the eights place. So, kind of from that to 12. What the fuck? But even if I do that, huh? Hold on, you muskrat. 1. Okay, so yeah, that's 13. I got that right. So if I added another 1 right there, what would that be? Would that make it 23? Because that's the 8th place, and after that would be the 10th place, right? So, yeah, you would have the 10th place right there. That would make it 23. So first of all the digits would have to be binary. All 5 of them. So it would be 10, 8, oh, okay. Okay, I see where I'm fucking up at. I got it fucked up in my mind. Okay, so after the 8th place would be the 16th place, not the 10th place or all that other shit. See, my brain is thinking of this wrong. Okay, so let's start over again. So 5 ones. The first one would be the ones place. The second one would be the twos place. Then with that would be the fourth place. Then we have the 8th place, and then the 16th place. And then after that would be 32, 64, all that good shit. So the question is actually 16 plus 8 plus 4 plus 2 plus 1. 16 plus 8, that's 24. 4 plus 24, that's 28. 28 plus 2, that's 30. Then 30 plus 1, that's 31. Okay. I wasn't thinking of it like exponentially growing. I was thinking of it as 2, 4, 6, 8, which I shouldn't have been thinking of because there's no 6th place in, this fucking binary right here. It went straight from 4 to 8. That should have clued me in. Bitwise and operator. Bitwise operators are similar to logical operators, but instead of operating on Boolean values, they apply the same logic to all the bits in the value by column. For example, say you had the numbers 5 and 7. Hold up. I think I want to take all this mess too, honestly. Yeah, I should probably take this. as like notes. Now I can read binary, grandmother. I have a computer for a brain. Fuck your copy icon. Alright, not reread this. Bitwise operators are similar to logical operators, but instead of operating on Boolean values, they apply the same logic to all the bits in a value by column. For example, say you had the numbers 5 and 7 represented in binary. You could perform a bitwise AND operation, and the result would be 5. 7. These operators select logical operators. Ah, okay. So it's the same thing, we're just putting it in a different way, I guess. But why would the result be 5? Okay. So instead of operating on Boolean values, they apply the same logic to all the bits in a value by column. Okay, so it was about to tell me down here. A 1 in binary is the same as true, while 0 is false. So really a bitwise operation is just a bunch of logical operations that are completed in tandem by a column. Okay, so let me ask this. So 1 and 1, that's true. 0 and 1, that's false. 1 and 1, that's true. 0 and 1, that's true. So because everything is mostly true instead of mostly false, that's why it picked 5, is what I'm thinking. I'll have to test that out. See if my thought process is true later. 1 in binary is the same as true, while 0 is false. So really bitwise, yeah. I completed a tandem by column. Ampersand, the fuck? Ampersand AND is the bitwise AND operator in Python. AND is the name of the bitwise operation, while ampersand AND is the symbol for that operation. For example, 5 and 7 equals 5, while 5 and 2 equals 0. So what is... okay, so that's saying that is true. And 5 and 2, that's false, that's false, that's false, and that's true. Okay, so that's... So what if I changed that one to that one? It would be equal, so what would it be? Binary notation. When writing a number in binary, the prefix 0b is used to indicate that what follows is a binary number. 0b10 is 2 in binary, but 10 without the 0b prefix is simply 10. 0b101, I mean 0b0101 is 5. 0b0111 is 7. Putting it together, that equals 5. Binary 5 equals blah blah. Binary 7 equals that. Binary 5 and binary 7 equals 5. Below D is framework. Anything else?
In modern web development, it can feel like bitwise operators are the kind of low-level primitives that only Arch users and Torvalds himself use, but that's only partially true. Bitwise operations are used all the time to build authorization systems, squeeze data into tight places for optimal storage, and ensure your network communications are error-free. Before diving into the bitwise AND operator, let's have a quick refresher on the logical AND operator. It operates on two Boolean or true-false inputs, and it only evaluates to true if both of its inputs are true. So for me to be a tall, handsome person, I need to be both tall and handsome, and as long as my mom is judging, I'm all set. Now, the bitwise AND operator is just like the logical AND operator, but it works with binary numbers. The binary digit 1 is the logical true, and 0 is false. So, a bitwise operation is really just a bundle of logical operations. So, for example, let's take the numbers 5 and 7. First, let's write them out in binary notation. Then, we'll just do an AND operation on each bit individually and build a resulting binary number. It's important to understand that a binary AND operation will always reduce the total number of ones in the output, which is why it's called masking or filtering. For example, if I have a large, seemingly random binary number, I can mask it with a number that has trailing zeros. And that just means that I only want to keep the first half of the original number and zero out the rest. I really hope this explanation helped. Please like the video and subscribe to the channel if it did.
Kinda sorta did. I don't know why you would, I don't know why you want to do that, but yeah. Guild permissions. Sometimes applications store user permissions as binary values. If I have 4 different permissions a user can have, then I can store that as a 4-digit binary number. And if a certain bit is present, I know the permission is enabled. This can be a lot more efficient than storing entire strings. Let's pretend we have 4 permissions related to guilds and Fantasy Quest. Guild is just a fancy video game word for team. Yeah, I know that big dog, I know that big daddy. Leftmost bit 1 can review guild. Can delete guild, da-da. Can edit guild, da-da-da. Come here, ginger ale. Sweet life blood. If a user has no permissions, their binary permissions would be 0000. If a user only has the can create build permission, their binary permissions would be 0. But a user with the can review guild and can edit guild permissions would be that. Alright, I understand it. I get that. To check for, say, the can review build permission, we can perform a bitwise AND operation on the user's permissions and the enabled can review guild bit. If the result is that again, we know they have that specific permission. Assignment. Get create bits. Simply use the bitwise AND operation on the input of the user's permission bits and the appropriate guild permission bits of variable, and return the resulting bits for them to be checked by the tests. The last thing, it's not. It's gonna teach us some other shit. And create guild. And review guild. And delete guild. And review guild. No, not review. Which one's the last one? Edit. You typing this right? Oh, hold on. Oh no, I can do it that way because it's already been declared in the outside in the global scope. We're good. Jesus Christ. There you go. But what should I run it against? Should I just run it against this? Should I just run it against itself? Let me see something. This is as much of a test as it is anything else, to be honest with you. These things, okay, yeah. They're going down that way. All right. Zeros and decimal integer. Okay, what if I do this? Okay, you're saying that's invalid syntax. Oh, I should be doing it by user permissions. To check for, say, the can review guild permission, we can perform a bitwise and operation on the user permissions and the enabled can review guild bit. Okay. So what are the user permissions, or is that, do I even know what they are? How do I know what the user permissions are? Or are you saying I don't need to know? Because user permissions aren't up there. Unless you want me to just copy this user permissions. So what can you do? You can edit the guild and you can review the guild, but you cannot delete or create it. Okay. That makes sense. So user review guild permission. Let me see this one. Okay, this one's confusing me a bit because this one is like more involved, more wordy than anything else. Can be used a bitwise and operation on the input of the user's permission bits and the appropriate guild permission bits variable, and return the resulting bits for them to be checked by the tests. Let's just do a little something here. We know what we have to return. All right, now let's work through the problem in my head. So, create guild mission. User permissions and create guild. What the fuck you think you're doing, bitch? Get out of here with all that mess. You can create guild. User permissions. Create guild permission. Can review guild. Or can create guild. And passed who failed. No. What did you want the user permissions to be? Hold on. It might be something as simple as this. Oh, still. All right. Back up. Back the fuck up. Complete each of the get XX bit functions. Simply use the bitwise and operation on the input of the user's permission bits and the appropriate guild permission bits a variable and return the resulting bits for them to be checked by the tests. 4 values have been provided. Use the appropriate one for each function. All right, my mind's starting to. It's starting to go. The dementia's setting in. This thing is very simple, but I'm having a brain fart right now. You're expecting everything to be false, but everything is true instead. How? I can understand why edit guild might be true. I can understand why review guild would be true. Because we should be using and. Yeah, we're using and. Maybe we should take a little break from this. Yeah, okay. Let's take a break.